And we're back with the Daily Space Weather Show after taking a whopping 1-day hiatus. We might explain why later, but in any case, we'll be showing the close-up imagery, the zoomed-out imagery. Will that be the filament that ends civilization? Let us know what you think in the comments. But the answer is no. Will that filament over there in the east end civilization? Well, the answer is no. We do have some CMEs to cover today. Let's take a look at the southern hemisphere for a minute. And multiple coronal mass ejection events jumping off in various different directions. We'll get to it. And yes, one is likely earthly directed. Here's a little close-up of a new little active region rising there. Doesn't look like it's likely a sunspot. Just showing some close-up action there for you. And here's the entire northern hemisphere. Some major filament activity also on the Earth-facing portion of the solar disk as the sun continues to play plasma miser. Yeah, plasma miser. Withholding plasma. How dare you? How dare you withhold plasma from Earth? It's out of control. And let's take a moment to see what's going on with plasma miser's solar cycle 25 sunspots for today, January 14th. Looks like a little dip in sunspot number since yesterday. There's colorized magnetogram. At least one new active region rose, it looks like. We'll get the sunspot number here in a moment. First, volcanoes. Volcanoes are next, and this is what was going on earlier at Iceland. So, some lava making its way to the sea there, and burning some houses on the way. You can see some measures taken here to attempt to direct the lava flow, obviously. And some new real estate being created there at Iceland. Here's what's currently going on there. Looking toward the town of Grindavik, which has been largely evacuated. Multiple different lava spewing ramparts there forming up on a lengthy fissure zone. Something like 450 meters. Anyway, I won't read the whole thing, but volcanodiscovery.com's Volcanoes Today page has got the full story about it and some spectacular imagery to follow. Check it out. Portions of the lava there reaching the sea, and here comes some fresh imagery for you. Looks like quite a bit of outgassing occurring there as well. So, major eruption going on there. Here's another. I don't think I can make it full screen, folks. But anyway, lots of stuff about it there at volcanodiscovery.com. Here are the other volcanoes erupting. Luatobi, Semeru, Ambrim on Vanuatu, Popocatépetl, San Chiquito, Fuego, Nevado de Ruiz, Sangay, Revenador, and Sabancaya. And this is the earthquake situation. Those are the earthquakes over the past 90 days. And let's break it down at the USGS site to see the 5 and greater magnitude quakes at least. No, it is not because we think space weather causes earthquakes. Chile had a 5.2. That was at 8:13 this morning. It was at depth over 120 kilometers. That's it, only one quake, and not likely to have been felt by a lot of people there. That was deep and deep in the mountains, I believe, near the Bolivia-Chile border. Not sure if anybody lives there or not. I don't think so. It looks pretty empty to me. Anyway, only one quake for the past 24 hours. And let's get to some space stats. 10.7 centimeter radio flux, now at 188 solar flux units. There's the 1 year. The black line is the radio flux. Space weather enthusiast dashboard, not forecasting any geomagnetic storms. I tend to agree. Although I did not do space weather yesterday, so I'm at a loss for that. Next Earth magnetic moment from space. Here are the past 4 hours. We do have some varying solar wind coming in. We'll get to it here momentarily, seeing a variation of around 150 kilometers per second there. So you can see some of that activity happening there. We'll get to it in a moment. So aurora chasers might have some luck tonight. There are some significant aurora likely. We do have some elevated solar wind conditions, but they are minor. So these are the places you might be likely to see it in the past 4 hours. The last 4 hours of Earth magnetic moment from space showing you where telluric currents would be likely, for example. Our geospace ground magnetic perturbations map. Speaking of ground magnetic perturbations, KP index is currently at 2. KP2 is the average global geomagnetism. Strangely enough, the ACE is not returning any data. If you try to get the data from the ACE, it shows you a blank screen and says Discover. So here's Discover. And like I said, we're seeing a variation in the solar wind here of 150 kilometers per second. So here it was only 330 or so. Here it was 480. So two different regimes of solar wind happening there, or perhaps some switchbacks happening, but more likely two different regimes because I see a clear signal among both speeds and densities. So you've got a different density here also, density varying about 3 or 4 protons per cubic centimeter. And also a solid pair of signals there for the plasma temperature. A little bit more sporadic for temperature, but you're still seeing at least 2 or 3 different separate temperature signatures there. That's the green bar at the bottom. Current conditions are kind of slow, 330 kilometers a second. Solar wind density about 7.35 protons per cubic centimeter. Next to goes magnetometers, and there you go. No space weather storms coming in, but we are seeing some variations there. Not too surprising considering the pretty wild variations in the solar wind speed. Next, our top view ecliptic plane field plot, and Earth remains in a North Pole magnetic sector. So there it is. What more can I say? Line of sight field plot looking like this. That's a lot of info over the past 4 days. Photosphere magnetism, polar fields, and the solar B field all at once. Next, line of sight coronal hole plot. And what do you got? North Pole oriented coronal holes on the Earth side of the solar disk, except in the north and northwest. So let's take a look at those. There we go. So up here we have south coronal holes. These are South Pole. The rest of these are North Pole. We also have a triangularly shaped coronal hole here, which could mean that insectoids are going to take over the universe, or that your chakras aren't aligned, or perhaps it's going to activate Lower frequencies, bro. It could be activating lower frequencies, bro. In which case, your whole mojo might be like out of whack until a thing goes out of retrograde or something. Anyway, let's get the sunspots. And we still have about 160 sunspots is the current sunspot number. Maybe 161, something like that. 160. And by the way, I just wanted to once again thank Eugene for doing this segment that explains the lines on this graph. I'm going to have to make him do a second one that explains this stuff, because this was the main thing that I actually wanted him to explain. But it was still good. He went in depth into how these lines are derived, so that's good. Make sure you're subscribed to Eugene's channel, by the way. Eugene the Philosopher. There are his most popular videos. Make sure you subscribe if you haven't, as Eugene slowly makes his way to 1,000 subscribers so he can finally monetize his channel and play ads at will. If you want to contribute to the segment, you can do so at smashomash.com/forum. So check that out if you haven't. smashomash.com/forum is where you can submit questions to the Ask a Particle Physicist segment. If you like, it's entirely free. We have the forum there so people can easily exchange information with virtually no censorship. Basically, all legal speech is protected on the forum. Next, getting to sunspots in more detail. Oh my dear God. It's a race, it's a chase. Hurry up and show what's going on in space. So we do have a significant likelihood of solar flares, but things have been pretty quiet. No major flaring activity. Let's take a look at sunspots from SDO. There is the SDO continuum plus 171 angstrom 60-minute running difference for the past 24 hours. For today, January 14th, 2024. And let's show the magnetogram also. There's the magnetogram plus 171 angstroms running difference. And next we'll drop the 171 angstroms. There's the magnetogram by itself. And looks like no major changes to me. I don't see any major growth or decay of sunspots here at the moment. Pretty stable for the past 24 hours. I guess yesterday was a pretty good day to take off. And yeah, maybe I'll explain reasons why. Here's SDO continuum. So that's, yeah, I think there are some sunspots that aren't going to be counted. So sunspot number is going to rise tomorrow back to about 175. 175, maybe 180 sunspots by tomorrow, as there are at least 2 groups not counted yet, certainly by where they're located there. So besides that, nope. Well, no, actually, some growth up here, I think. There's some growth up here. Oh, yeah, big time growth up here. So probably be at about, well, 180, 185, maybe even 190 sunspots by tomorrow, assuming none of these other groups decay. So, yeah, uptick in the sunspot number coming. And let's get to flares and so on. So a little tiny proton signal happening here. Some relativistic particles showing up at Earth. Detectable at the GOES 16 and GOES 18 from their geosynchronous near equatorial orbits. Little spike in the proton flux there, but barely enough to even mention. Probably from this longer duration flare right here, or associated with it. It was almost an M-class event. It came from a region behind the western limb, which we'll show you next. So there's the full disk view, and right back here right there was that M-class flare event, and it looked like a major event on the opposite side. So you can see a huge halo form at that same time. There looks like there was a major solar flare and possibly CME event on the far side of the sun. Typical of why you see that sudden halo right there. So you'll be able to see that again here from this perspective. Just after that nearly M-class flare at the western limb. And there it goes. So, and again, there were some coronal mass ejections that went on. I think one of them has some earthly directed components. So we'll get to that here in a moment. First, a star chart. Oh, first 94 angstroms. How about that? Another 24-hour video from Solar Dynamics Observatory. It's so doggone good, the SDO. Next, like I said, a star chart. And, yeah. That's what's next. Cheers. That's what's going on over our head. And making the video a little earlier, it is Sunday. So, yeah, Sunday edition here, slightly earlier. Perhaps at a slightly lower speed, but that's what's going on. You've got the constellation Cygnus high up in the sky there as it circles Polaris all winter long, and the sun in a setting mode there on the ecliptic. Next, we'll show the solar system forecast, things today. Things in 7 days. We will have a gibbous waxing moon by the 21st. And let's move on to CMEs. But first, the astronomy photo of the day from Iceland. A very dragon-like or perhaps phoenix-like aurora. And yes, the brightness and contrast and saturation were messed with on that, I would suspect. However, it's not super easy to catch that much of the aurora, so it might be a little more difficult than it looks. There's the full image. Not half bad. apod.nasa.gov. Next, CMEs. Yeah, CMEs. You gotta have them. And sometimes they're headed in our direction. So I think there was one minor one that is earthly directed here. It's the one that is out of the south? Something doesn't look right. This one out of the south? No. I thought it was out of the southeast, so hold on a minute here. Yeah, I'm not so sure. Not so sure that's earthly directed, folks. Let's move on to we'll put the C3 and C2 up there. And what do you got? That really big one out of the west is definitely not earthly directed. It's from behind the limb. So it can send protons without being earthly directed for sure. And that's exactly what's happened. So again, I'm pretty sure there is one here, this one out of the southeast that you can kind of see on the C3. There is an earthly directed component there, I'm pretty sure. So we can expect a minor CME impact on, that would be sometime late day the 17th. Maybe midday the 17th. Mid to late day the 17th of January. So could see a minor CME impact. It won't cause major geomagnetic storms. Multiple events popping off there at the same time, making it as confusing as possible. We should see some filament motions right in this area here. And there's some hider flare activity right up here and up here. So there's multiple events sort of happening in a period of several hours there, and yeah, there is one Earth-directed component in there. Multiple CMEs happening throughout the day today. Not exactly the easiest forecast there. This will show it a little bit better. And you'll see some brightening happening up here. Also some brightening down here. That's plasma splashing back down toward the chromosphere. The layer in between the photosphere where sunspots occur and the corona, which is where the SDO imagery that we're showing is derived. So there's a filament right in here that ejects, and then there's one up here that ejects, and one or both of those could be earthly directed. So we might even have a double impact there, but I would suspect at least one of those will have an earthly directed component. Again, arrival sometime mid to late day on January 17th. That's the analysis. And let's move on to, well, I'll show that imagery one more time. There we go. The full equatorial view, 304 angstroms SDO plus 193 angstroms, 60-minute running difference. Shows fantastic depth and action happening. Next is filaments, and there are filaments from Cerro Tololo, Chile. And we do have some prominences rising down here in the southeast, so that's likely a sunspot down there. And there may be one hiding back here as well. I am seeing some towering filaments throughout the day today, so at least 2 more, maybe 3 more new prominences showing up there around the east. Here's the colored imagery. And yeah, so 2 or 3 more sunspots here could rise in the next day or so based on what we already have. So again, looking for a small uptick in sunspot number, maybe up to 185 by tomorrow, 180, 185, something like that. As we've got at least 2 or 3 new groups that should get named, and one with a lot of sub-sunspots added to it. So, and before we get to bonus features, don't forget to name that filament, by the way. If you've got filaments you'd like to name after your friends, your foes, or even yourself, here's how you do it. Just copy the image, come over here. Nope, don't go over there. Come over here and type the hashtag name that filament, and then tag me like that. And then type in who you want to name it after. Who to name it after? Your friends, your foes, some celebrity who you don't know at all, or even yourself. Why not? Name that filament. Follow the hashtag on Twitter. Yeah, the brand. You know, the brand Twitter. Anyway, there are the last couple of hours, and it's been pretty quiet, actually. So let's get the bonus features. First, we'll show you the full disk so you can see the timestamps from the GOES 16 SUVI. Next, satellite charging hazards. We don't have them. It's smooth out there. Oh, some minor surface charging there around India. Surface charging around India won't cause any major communications errors, if any at all. GOES electron flux here is kind of low, and it's been low. And the forecast is for it to stay low, I think. There's the past year. And seeing sort of an extended electron shortage there. Which is also, by the way, not apocalypse-ish at all. And here we have a minor uptick. And we are seeing some elevated solar wind, so that would be a reason to see a minor uptick in the electron flux. So, I mean, there you go. A delayed sort of a thing there. So, yeah, I would tend to agree. I would tend to agree with NOAA's forecast there for a mild uptick in electron flux. We'll also show the layer where it's measured. The F layer. And there it is in vibrational frequency. bro, whatever you do, don't be around this area up here, okay? Because it's at low vibrational frequency, okay? If you're under the ionosphere and it's at low vibrational frequency, it's going to light up all of your... It's going to be plugged directly into your kidneys, bruh. Pardon my mockery of flim-flam bamboozlery. Anyway, here's the anomalygram. And quite a bit of high-frequency anomaly happening. Because it's very diffuse. Yeah, the gas in the ionosphere, it's very diffuse. There's not a lot going on. We haven't had any proper space weather for an extended period. So hence you've got lots of high frequency. Ionosphere, it is a very settled ionosphere at the moment. We'll also show the total electron content forecast, the total electron content and the maximum usable frequency, which is the global ionosphere nowcast, the whole atmosphere model, or WAM. Oh, some very high electron contents happening there over the Central Pacific Ocean. Very high electron contents indeed. So some major GPS errors likely to be happening there. That would be free electrons from about 12,500 miles of altitude down to ground level. DAG, major GPS errors over Hawaii, for example. Anyway, don't forget to press the like button if you enjoy the content. Tell your friends and foes about us. Press share. If you're new to the channel, press subscribe. Otherwise, you might miss the world's most detailed solar imagery and the most comprehensive daily space weather content. Only for the past 6 years or so. Where have you been if you're new? What's that? You didn't know the channel existed? Oh, that's impossible. I couldn't imagine how that could be the case. Pardon my sarcasm. Press the like button, or else. We'll close out space weather with the high-res images. There's continuum. There's magnetogram. Here's the rock back. And here's the meteorology segment. First thing we're looking at is the tripled up jet stream. Yeah, we got a tripled up jet stream over the U.S. right now, folks. So check it out. This is one of the major components of what's going on in the weather right now. We have 198 mile per hour winds at the 250 millibar or the 250 hectopascal signal. So there you go. Nearly 200 mile per hour jet stream happening there, folks. And that is causing various things to happen. So it's creating a relative low pressure. It's creating a relative upper level low behind it. But it's also pulling weather behind it. So, and you can see we've got a tripled up jet stream. Here's 1, here's 2, and here's 3. And then a massive convergence right here in the North Atlantic. So that's part of what's driving the weather. And let's get to the jet streams on a global scale. So there are the jet streams for the eastern world. Here are the surface winds. Surface winds of the central world. Strong storm here off the coast of Madagascar. Strong system there. Looks like hurricane force perhaps. At least 77 mile per hour winds, so that is indeed quite a strong system. That is at least a Cat 1 hurricane. Jet streams of the central world depicted here. Jet streams of the west. And surface winds. It's very dangerous conditions on the Great Lakes right now. Very, very strong winds, especially on Erie. Like 40 mile per hour winds, sustained winds. So here are clouds and fog for the Americas. The shortwave radiation map. Clouds and fog, they emit IR radiation. That's infrared. The satellite sees all. And here's a little close-up of the Great Lakes region again. Really high winds on especially Erie and Ontario. But the other Great Lakes, indeed, very windy also. So check it out, 40 mile per hour sustained winds there across, well, Ontario's the windiest, followed by Erie. But check it out here we got like nearly 50 mile per hour winds. Out in the Atlantic, well, 45, okay, 45 mile per hour winds. And of course the story will be cold temperatures. So let's show temperature briefly. And the coldest part of the U.S. right now, as far as the lower 48 goes, is up here in Montana for sure. Negative 23 Fahrenheit near the Canadian border. Yowzers. That is on the cool side. And of course, you'll hear lots of cold warnings and so on. A bunch of record temperatures getting broken, which will trigger some people and have other people celebrating for some reason. It's bizarre. Anyway, there's the key for the weather.gov map. Weather.gov, the National Weather Service homepage. Check it out if your location is lit. And here comes some forecasts. First, the GFS 72-hour accumulated positive snow depth change forecast in inches. And lots more snow coming, some for us this time. So always excited about that. Fingers crossed for some quality snow here in Lehigh Valley, PA. Anyway, there's the map. I'm not going to try to explain it. That's why I'm showing it to you. Hit next the jet stream forecast, and of course the jet stream is largely responsible for major swings in temperature. You can see that little kink there making its way across the Great Lakes toward the east. That is the Canadian cold snap, which will largely break up by the time it reaches New England. It's not going to be nearly as cold by that point. And here's the temperature anomaly map in degrees Celsius. 72-hour GFS temperature anomaly in degrees Celsius. Tennessee will be seeing some temperatures 20 degrees Celsius below normal for this time of year. And that's 20 degrees Celsius. Those are big degrees. Anyway, here is lightning. Lightning is next. And the Atlantic Ocean featuring a bunch of lightning, as well as Brazil. A ton of lightning there in Brazil. And there you can see that Atlantic lightning. What is up with that? I thought they had sensors in South America. Pretty sure they have sensors. Maybe not. All right, I guess they don't have sensors down there. Because it's clearly not. There must be some thunderstorms, right? Anyway. Is that the Azores? Ah, yes, the Azores. That's on my bucket list. What about you? One of the old school pirate lairs, right? Anyway, we'll close out this video with U.S. Doppler. There's the full 50 state view. Wait, there we go. And we have some snow happening here. Looks like it's snowing in parts of Tennessee and Kentucky, folks. Here is clouds and fog. And there is the water vapor map. Just two significant pockets of moisture there making their way across the country at the moment. Bringing a little bit of precip with them. Here's your recap to close out this video. U.S. Doppler radar. Clouds and fog. Water vapor. And me heading back to the bunker. I'm going back to the bunker, even though heat rises. Anyway, see you soon. In the meantime, may that solar wind be at your back. Whoa!